Hello, everyone. My name is Andrew Hamilton. I'm a postdoctoral fellow at University of Alberta, and I'm going to talk to you today about ice-ocean interactions in the Canadian High Arctic and the voyages of the polar yacht Vagabond. Now, this is very collaborative work. We have quite a large group of people working on this project. Here's a list of most of them. No doubt I've missed a few, so I apologize for that. But I want to specifically thank the Vagabond crew, Eric Brossier, France, Leonie, and Aurore for their active participation in these projects over the past 3 years, as well as want to really single out the hamlet of Grise Fiord or Asuituk, who have been very supportive of our project, and that's where the Vagabond has been based for some of this time, as well as the hamlet of Arctic Bay. Now, our research is basically broken down into 3 main research questions and research groups. So I'm going to give you a very brief overview of each of these questions. First off, Jochen Halfar and collaborators at the University of Toronto ask, how has the extent of Arctic sea ice changed over the past centuries? Now, we know from satellite records, which began in 1979, that Arctic sea ice extent has been declining steadily over the past 42 years. However, this record only spans the past 42 years. So it's somewhat truncated, and we don't have longer context of how these sea ice, how the sea ice decrease fits into the longer historical scale. And Jochen and his colleagues addressed this question by looking at coralline algae. Now, coralline algae is a photosynthetic organism that grows in shallow seas, which grows like the rings of a tree. And so each ring is dependent on the level of light, which is sea ice dependent, and temperature of the ocean. And by analyzing the rings in these coralline algae, you can get a record of past climate. And that can extend our sea ice records over hundreds of years. And so Jochen and colleagues have actually extended sea ice records back over 650 years, beginning around the year 1400, and shown that sea ice has decreased and increased at times, but the more recent decrease over the last few decades is rather unprecedented. Okay, so what Jochen needs is he requires coralline algae collection over a large geographic area to really constrain the spatial extent of this sea ice decrease. Our next group, which Maya Batia and others are asking, how are glaciers impacting water column properties and nutrient delivery to the euphotic zone in the Canadian Arctic? And so in this group, they're looking at primary production in the marine ecosystem, and the primary production is limited by macro and micronutrients. So macronutrients being nutrients such as nitrate, and micronutrients being metals such as iron, which are in low concentrations at times of year in places like Jones Sound and Nunavut. And what they're looking at is how glaciers, and specifically meltwater runoff from glaciers, can influence nutrient cycling in the ocean and affect primary productivity. Now, nutrients can come to the ocean from glaciers in a variety of methods, one of which is by subglacial discharge, which comes out at near the bed of a glacier and then upwells as a buoyant freshwater plume. And with it, it can entrain deep seawater and bring deep nutrient-rich seawater towards the surface. And another method, of course, is actual glacial meltwater running off the glaciers, which can be rich in metals such as iron, and that can flow directly into the ocean and seed the ocean with those micronutrients. So Maya and her team, they require repeat marine biogeochemical sampling in the Canadian Arctic to really understand these processes in detail. Now, a group that I'm involved with, we're asking, is a deep, warm Atlantic water driving retreat of glaciers in the Canadian Arctic? And the reason we're asking this is because it's been shown along the coast of Greenland that there has been quite a bit of Atlantic warming, basically a pulse of Atlantic water that went northward up the coast around the year 2010. And that can influence glaciers when this deep Atlantic water is able to propagate right to the termini of glaciers, can increase submarine melting and therefore drive acceleration and retreat of the terminus of the glaciers. And what we want to know is the same thing happening in the Canadian Arctic. Is this Atlantic water able to get over And one site in particular is highlighted in this red box, which is a research site of Talbot Inlet. And so the red arrows here show you a hypothesized pathway of Atlantic water. And we want to know, is it deep enough on the shore for this Atlantic water to actually get into these inlets and drive the very fast flowing glaciers that we're seeing, two in particular, Trinity and Wycombe glaciers, which are the fastest flowing glaciers in Canada and account for over 50% of all icebergs produced from Canadian glaciers. And in order to understand these questions, it requires seabed mapping and repeat ocean measurements at these sites and many others, in particularly the uncharted waters of the Canadian Arctic. So how do we go about this? Well, first of all, the problem is there's a lack of in situ coastal observations in the Canadian high Arctic, and our options are a few to address this question. We can use large icebreakers, which we've certainly done. We can do sea ice camps, which we have also done, and community collaborations, which are ongoing and very productive. But another method is smaller ice strengthened coastal vessels. And enter the sailing yacht Vagabond, which is crewed by Eric, France, Aurore, and Leone. And they've spent the past 2 decades basically living in the Arctic on their sailboat, assisting researchers to conduct science. The Glaciers are very connected to the environment and like to get up close and personal and get their hands into the work that they're doing. So they're excellent collaborators for our scientific team. And so what we've done over the past 3 years from 2019 is we've had the Vagabond do multiple cruises. In 2019, they started out in southern Greenland and actually cruised through Greenland and into Canadian Arctic waters with a focus around Devon Island, Jones Sound, and eastern Ellesmere Island. We did a similar cruise track in 2020, where they had overwintered in Arctic Bay and then entered Jones Sound. And in fact, the cruise actually stopped near Grise Fiord that year. And then this past year in 2021, the cruise started in Grise Fiord and headed up around the east coast of Ellesmere Island and then returned and sampled a couple sites on northern Devon Island. What we do on these cruises, we do a vast amount of CTD profiling to collect ocean properties. We collect water bottle samples. We have a wet lab on board for filtering and analysis. We installed a multi-beam echo sounder to map the seafloor. Eric is a scuba diver and collects coralline algae samples on the go. And we've also deployed ocean moorings off the Vagabond. So what are some of the challenges we've encountered over the past 3 years? Well, I'll just highlight a few. Ice hazards are obviously a big one. The coast of Greenland can be relatively sea ice free in the summertime, whereas the coast of Ellesmere Island in particular can have still quite a bit of sea ice. And these are some of the conditions that the Vagabond has to get through in order to conduct science. We also, of course, have to deal with weather in a large sea state on a relatively small ocean-going vessel, which can provide its own challenges. And we have to deal with typical fieldwork issues like broken gear. So we've done some multi-beam mapping of the glacier termini and bed in front of glaciers. But when you're working in ice-covered waters, you can tend to break these pole mounts and come close to losing your multi-hundreds of $1,000 instruments. Other lesser known hazards are falling rocket debris from Russian rockets, which tend to fall in our research area, so we have to be aware of those. But beyond the challenges, we've actually found that this vessel has lots of advantages. We're able to access otherwise inaccessible sites. We can adapt with our small crew, and you're quite immersed in your environment where you can learn from the real experts, which include the Glaciers and the communities that we're connected with. But most importantly, this has been a very productive sampling effort for us. Over the past 3 years, we've conducted 3,500 square kilometers of seabed mapping with multi-beam. We've collected 2,000 coralline algae samples, over 200 CTD profiles and water bottle samples with all the biogeochemical samples that go with that. Eric's done over 65 scuba dives We've deployed 2 ocean moorings and collected a weather station that we covered. So really the possibilities are quite endless with this method of doing science. So we have plans for 2022 to conduct another research cruise in collaboration with some local boats that we're doing work with in Jones Sound. And I encourage you to visit Maya Batia's poster on the changing coastal environment in Jones Sound. And I want to thank you very much for your attention and time.